Deep space holds structures so strange they defy all known physics. This journey through 22 bizarre cosmic anomalies will leave you questioning the very nature of reality. We will uncover mysterious megastructures and geometric formations that have stumped our greatest scientists. You will discover the leading theories behind these enigmas and learn why they remain some of astronomy's biggest unsolved puzzles. What if a star's dimming is caused by an alien megastructure? How can a galaxy form a perfect ring? By the end, you will see the universe as a place of endless wonder and mystery. What do you believe is waiting for us in the cosmic dark? In 1977, a radio telescope in Ohio captured something that would send a chill through the scientific community. It was a powerful burst of radio waves so unusual that an astronomer circled the printed data and simply wrote, "Wow." This event, lasting just 72 seconds, has never been repeated and has never been fully explained. We call this the wow signal, and it stands as our first bizarre structure, not of metal and rock, but of pure energy, a potential beacon from the void. The man who discovered it, Dr. Jerry Amon, noted its startling characteristics. The signal was both narrowband and intense, focused on one specific frequency with a strength that dwarfed the background noise of space. This frequency is particularly telling as it aligns perfectly with the hydrogen line, a natural emission from the most common element in the universe. Many scientists have argued this would be a logical channel for any civilization attempting to make contact, a universal calling card written in the language of the cosmos. So what could have caused it? Was it a natural cosmic event we simply do not yet understand, a glitch from a passing human satellite, or could it genuinely be our first whisper from another intelligence? Decades of searching the same patch of sky have yielded only silence, deepening the mystery. The wow signal forces us to confront the sheer difficulty of our search. We are listening for a voice in a hurricane of cosmic noise, and for one brief moment we may have heard one. This single, unexplained event reshapes our entire approach to the unknown, proving that the most profound structures in space might not be things we can see, but signals we can barely hear. That tantalizing whisper from the void was just the beginning. Far from being a fleeting signal, our next enigma is a star that behaves unlike any other in our galaxy. Officially catalogued as KIC 8462852, it is known to the world as Tabby star, named for the astronomer Tabitha Boyajian who led its investigation. This star, located over 1,000 light-years away, does something profoundly strange. It does not pulse with a steady rhythm, nor does it dim gently as a planet passes in front of it. Instead, its light drops in erratic, dramatic plunges, sometimes by as much as 22%. This is not the subtle shadow of a world, but the kind of deep, irregular dimming you would expect from a colossal, chaotic swarm of objects blocking its light. This bizarre behavior was first flagged not by a professional astronomer, but by citizen scientists, volunteers sifting through public data from the Kepler Space Telescope. They noticed the light curve was, in the words of Dr. Boyajian herself, bonkers. The pattern defied every conventional explanation. A planet would create a symmetrical, repeating dip. A dust cloud would scatter light in a predictable way, but this was a mess, a series of deep, jagged shadows with no discernible rhythm. This left scientists with a puzzle that demanded radical answers. The most startling hypothesis proposed by astronomer Jason Wright was that we might be seeing a Dyson swarm. Imagine a vast collection of energy-collecting platforms, built by an advanced civilization to completely envelop their star and harness its total power output. Such a structure, under construction and not yet complete, could create the exact kind of chaotic, deep dimming we observe. Of course, the scientific community raced to find a more natural cause. They investigated the possibility of a giant cloud of cometary fragments, or a recent planetary collision that filled the system with swirling debris. Yet each theory has struggled to fully explain the data. The cometary fragments would need to be impossibly large and numerous, and the dimming has persisted for years, which a one-time collision could not sustain. The megastructure hypothesis, while extraordinary, has stubbornly refused to be completely dismissed. It remains on the table not because it is the most likely answer, but because it is one of the few that has not yet been definitively ruled out by the evidence. This case is a powerful lesson in how a single, persistent anomaly can force us to expand our imagination, to consider that we might be looking at the signature of intelligence on a scale we can barely comprehend. It propels us from listening for whispers to staring at the shadow of a possible colossus, and from here we must look at shapes etched into the very fabric of space itself. While we stare at distant stars, a visitor from the void slipped right through our cosmic neighborhood. In 2017, astronomers in Hawaii spotted the first known interstellar object to pass through our solar system, a tiny, fast-moving speck they named Oumuamua, a Hawaiian word for scout. This was not just another asteroid or comet from our own system. It was a traveler from another star, and its behavior was utterly perplexing. Its shape alone was bizarre, a dramatically elongated object, perhaps 10 times longer than it was wide, tumbling through space like a cosmic cigar. But its strangeness went far deeper than its form. Most comets, when they approach the sun, develop a fuzzy coma and a tail as their ice heats up and releases gas and dust. Oumuamua showed no such coma. It was dark, reddish, and seemingly inert. Then came the real puzzle. As it sped away from the sun, its trajectory could not be explained by gravity alone. It was accelerating as if pushed by an unseen force. For comets, this is usually caused by outgassing, where jets of vapor act like tiny thrusters. Yet no outgassing was ever detected. No dusty trail was left behind. This left a glaring hole in the explanation. It was this combination of mysteries that led Harvard astronomer Avi Loeb to propose a radical idea. He suggested Oumuamua could be a piece of advanced technology, perhaps a light sail, a thin, reflective sheet pushed by the radiation pressure from starlight. Its unusual brightness and its unexplained acceleration, he argued, were consistent with such an artificial object. The scientific community, of course, responded with intense debate. Many astronomers favor natural explanations, proposing it could be a chunk of solid hydrogen ice that slowly evaporated in sunlight, providing the thrust without visible gas, or a fragile, fractal-like dust aggregate. Yet each of these models struggles to perfectly fit all the data. The hydrogen iceberg, for instance, might not have survived its long journey through interstellar space. The core of the debate is not about proving aliens, but about our willingness to confront anomalies that challenge our existing models. Oumuamua was a brief, tantalizing guest. We only had a few weeks to observe it before it vanished back into the depths, leaving us with more questions than answers. It serves as a profound reminder that our solar system is not an island. The galaxy is constantly sending messengers our way, and the next one might not be so shy. What if the next interstellar object we find is not a silent, tumbling rock, but something broadcasting its presence for all to hear? This discovery of a transient interstellar object is humbling, but it pales in comparison to the scale of our next anomaly. a structure so immense it seems to challenge the foundational rules of the cosmos itself. Stretching across an almost unimaginable 3.3 billion light-years, astronomers have found a nearly symmetrical arc of galaxies hanging in the void. They call it simply the giant arc. To grasp its size, picture a line so long it would take light, the fastest thing in the universe, over 3 billion years to travel from one end to the other. This is not merely a big collection of galaxies, it is a pattern, a discernible structure on a scale that, according to our best theories, should not be possible. The cosmological principle is a cornerstone of modern astronomy, the idea that if you look at the universe on a sufficiently large scale, it should appear roughly the same everywhere, smooth and uniform, like the texture of a well-mixed cake. The giant arc is a glaring contradiction to that principle, a massive ripple in the cosmic fabric. This colossal formation was discovered not by looking at the galaxies directly, but by analyzing the light from distant quasars, the brilliant cores of active galaxies. By studying how this light filtered through vast clouds of intergalactic gas, a team led by astronomer Roger Clowes pieced together the arc's staggering outline. Clowes himself expressed profound astonishment, noting that such a gigantic structure simply should not exist under our standard model of the universe. Its very presence suggests that our understanding of how the cosmos evolved after the Big Bang is incomplete. What unknown forces could have sculpted the infant universe into such a vast and specific shape? Perhaps there are primordial conditions, wrinkles in space-time from the first moments of creation, that imprinted this pattern onto the expanding universe. The implications are staggering. Could this be a flaw in our models, or even evidence pointing toward more exotic ideas like a multiverse, where our universe is just one bubble among many, and the giant arc is the faint scar of a long-ago collision with another cosmic domain? This structure forces a complete reevaluation of the universe's architecture, proving that even when we look at the biggest picture possible, the cosmos is still capable of delivering shocking and beautiful surprises. After confronting a structure of impossible scale, we now face its chilling opposite, a cosmic desert of staggering emptiness known as the Boötes Void. Picture a sphere of near-total nothingness, a region of space so vast it could contain thousands of galaxies like our own, yet holds almost none. This is the Great Nothing, a void roughly 330 million light-years across that defies our basic expectations of the cosmos. When astronomers first mapped it in the 1980s, they were met with a profound silence. Where the universe should have been buzzing with the light of countless stars, there was only a deep, unsettling dark. Robert Kirshner and his team, who helped pioneer its study, noted that a void this immense is exceptionally rare. Our standard models suggest matter should be distributed far more evenly, not gathered into a dense cosmic web surrounding a gap of this magnitude. So how did this colossal empty space come to be? One leading theory points back to the universe's very first moments. Tiny quantum fluctuations, microscopic ripples in the newborn cosmos, may have been stretched to impossible sizes by the rapid inflation of the Big Bang. These primordial wrinkles could have created vast underdense regions, bubbles in the expanding fabric of space where matter simply never collected. Another, more mysterious possibility involves dark energy, the unknown force accelerating the universe's expansion. Perhaps its influence is not uniform, and in places like the Boötes Void, it acted with unusual strength, pushing matter apart and clearing a volume of space that would take light hundreds of millions of years to cross. But is this void truly empty? Its profound darkness might be hiding secrets of its own. Some scientists speculate these deserts could contain immense concentrations of dark matter, the invisible glue holding galaxies together, or other phenomena we cannot yet see with our telescopes. The Boötes Void stands as a monument to absence, a stark reminder that the universe's greatest mysteries are not only found in the brilliant clusters of galaxies, but also in the silent, empty spaces between them. From the profound emptiness between galaxies, we come to a shape of stunning precision right next door. At Saturn's North Pole, a perfect hexagon of clouds, some 30,000 kilometers wide, has held its form for decades. This is not a fleeting storm but a permanent atmospheric feature, a six-sided jet stream etched into the planet's sky that makes our own polar weather patterns look chaotic and formless. Its razor-sharp edges and unwavering geometry were first glimpsed by the Voyager probes, and it has been watched by the Cassini spacecraft ever since, a puzzle spinning in plain sight. How can a fluid, turbulent atmosphere produce and maintain such a rigid, geometric form? Experts like Kevin Baines have run complex fluid dynamics models to find an answer. The leading theory suggests it is a massive, stable standing wave, a pattern created by the interaction of different wind speeds and the planet's rapid rotation. Think of it like a cosmic version of the shapes you can create by vibrating a plate of water, where certain frequencies produce perfect polygons in the liquid. Saturn's deep atmosphere might be acting as that fluid, with its rotation providing the steady rhythm that locks the hexagon into place. Yet, even with these compelling models, the sheer stability and perfection of the hexagon remain deeply puzzling. Why six sides, and why has it not wavered or dissipated over time? This is not just a cloud pattern, it is a lesson in how nature can produce order from chaos, crafting a structure so precise it looks designed. It blurs the line between a known physical process and something that feels almost artificial, reminding us that our own solar system holds mysteries as profound as any distant galaxy. What other geometric secrets are hidden within the swirling atmospheres of gas giants, waiting to reshape our understanding of planetary science itself? Rising from the very heart of our galaxy are two colossal orbs of pure energy, each a towering testament to a forgotten cataclysm. These are the Fermi Bubbles, vast structures of gamma-ray light that balloon outward from the Milky Way's core, stretching 25,000 light-years above and below the galactic plane. To stand on Earth and look toward the center of our galaxy is to gaze directly at the base of one of these invisible, seething giants, a relic of violence on an almost unimaginable scale. They were discovered quite by accident in 2010, when a team of astronomers led by Doug Finkbeiner was sifting through data from the Fermi Gamma Ray Space Telescope. They were mapping the background haze of cosmic rays when they noticed an unmistakable, sharp-edged structure, a pair of symmetrical bubbles emitting some of the most energetic light in the universe. Their sheer symmetry pointed to a single titanic event, an eruption from the galactic center that occurred sometime in the last few million years. But what was the trigger? The prime suspect is our own galaxy's supermassive black hole, Sagittarius A*. While it is quiet today, it may have experienced a colossal feeding frenzy in the relatively recent past, devouring an enormous cloud of gas and dust. Such a feast would have generated unimaginable power, shooting out jets of superheated matter and radiation from its poles, essentially blowing these giant bubbles into intergalactic space. Another theory points not to the black hole but to a frenzy of star formation, a period where millions of stars were born all at once in the crowded galactic center, only for the most massive of them to quickly explode as supernova. This chain reaction of stellar births and deaths could have created a powerful galactic wind, blowing the observed bubbles outward. The true cause remains one of astrophysics' great debates. The Fermi Bubbles are a ghostly echo of a violent chapter in our galaxy's history, a reminder that the seemingly serene Milky Way has a far more turbulent and explosive past than we ever suspected. They prove that cataclysmic events can leave scars etched not in stone, but in the highest energy light, invisible to our eyes yet fundamental to the story of our cosmic home. These invisible giants of gamma-ray light are not the only force exerting its will on a cosmic scale. There is a current flowing through the universe itself, a mysterious and relentless pull that is dragging entire clusters of galaxies toward a point beyond the edge of everything we can see. This phenomenon is known as the dark flow, and its discovery sent shockwaves through cosmology. It began with a careful study of the cosmic microwave background, the faint afterglow of the Big Bang that fills all of space. By analyzing this primordial light, scientists led by Alexander Kashlinsky noticed something impossible. Vast collections of galaxy clusters, each containing thousands of galaxies, were all moving in a coordinated stream at incredible speeds, millions of miles per hour, toward a single direction in the cosmos. This was not the gentle, expanding drift of the universe. This was a purposeful, collective motion, as if the galaxies were leaves caught in a river flowing toward a colossal, unseen waterfall. The sheer force required to move such immense structures in unison defies all conventional explanation. Gravity from known matter in our observable universe is far too weak to account for it. So what is pulling them? The most profound and startling hypothesis is that the dark flow is evidence of something entirely outside our cosmic horizon. Our observable universe is a bubble of space from which light has had time to reach us since the Big Bang, but the cosmos does not simply end at that horizon. There could be more universe beyond it, vast realms of space and time we can never see. The dark flow suggests that immense concentrations of mass, perhaps other entire universes in a vast multiverse, are exerting a gravitational pull on our own from beyond the veil. Their titanic gravity is literally tugging on the fabric of our reality, creating this cosmic river. This idea challenges the very core of the cosmological principle, which assumes the universe is broadly the same in all directions. The dark flow reveals a startling anisotropy, a preferred direction on the grandest scale, hinting that our universe is not a lonely island but part of an archipelago of cosmic domains, each with its own physical laws and structure. To contemplate the dark flow is to stare into the ultimate abyss of our ignorance. It forces us to ask what lies beyond the limits of our vision, and what unimaginable structures, so vast they make our entire universe seem small, could possibly hold such sway over everything we know. This relentless cosmic flow finds a strange and beautiful echo in a frozen moment of stellar death. Suspended in the depths of space, 2,300 light-years from Earth, is a structure so geometrically perfect it seems to defy the very nature of chaos. Astronomers call it the Red Rectangle Nebula, and its name is not an exaggeration. Through a telescope, it appears as a near-perfect rectangle of deep crimson light, bisected by rungs of glowing gas that form a haunting, ladder-like structure. At its heart lies a dying binary star system known as HD 44179, a pair of aging suns locked in a final, elegant dance. Most nebulae, the clouds of gas and dust expelled by dying stars, are either spherical or wildly irregular. The red rectangle is neither. It is a bipolar nebula, meaning its material is funneled into two opposing cones, and from our vantage point, we are looking directly down the barrel of one of these cones, with the thick dust disk around the stars forming the apparent rungs of the ladder. The renowned astrophysicist Vincent Ike created computer models showing how the precise interaction between the central stars and their surrounding disk could sculpt such sharp, conical outflows. The stellar winds, he proposed, are collimated or squeezed by the disk, forcing the ejected gas into this breathtaking geometric shape. Yet the model's clinical explanation does little to diminish the awe of seeing such perfection. What processes could possibly maintain such razor-sharp angles and symmetry across trillions of miles of space? The vibrant red glow itself is another piece of the puzzle, caused not by common hydrogen gas, but by a class of complex organic molecules known as polycyclic aromatic hydrocarbons. These are essentially large molecules of carbon and hydrogen, the very building blocks of soot, illuminated by the intense ultraviolet light from the dying stars. The nebula represents a brief, brilliant phase in stellar evolution, a fleeting cosmic artwork that will dissipate into the void in just a few thousand years. The Red Rectangle stands as a powerful testament that nature, governed solely by physics and chance, is capable of producing forms of stunning precision and beauty. It requires no architect, only the unwavering application of physical laws. This celestial masterpiece challenges our perception of randomness, suggesting that even in death, the universe possesses an inherent artistry, a capacity for order that can stop us in our tracks and make us wonder what other perfect shapes are hidden in the dark. This relentless pull we feel is not just a theoretical curiosity, it has a specific destination. Our entire galaxy, along with countless others, is racing at over 1 million miles per hour toward a specific point in the darkness, a gravitational monster known as the Great Attractor. This colossal anomaly sits in the depths of intergalactic space, roughly 150 million light-years away, and it exerts a force so profound it bends the motion of galaxies on an epic scale. Its discovery came not from seeing it directly, but from listening to the subtle music of the cosmos. Astronomers mapping the universe noticed a strange deviation. While the universe is expanding, carrying all galaxies apart, our local cluster and thousands of others were also moving sideways, pushed off course by an immense, unseen tug. These peculiar velocities pointed like a compass needle to a single region of space, a place of overwhelming gravity. The great frustration is that this very region lies directly behind the crowded, dusty center of our own Milky Way, in an area astronomers call the zone of avoidance. It is like trying to see a distant city while standing in the glare of your own backyard light. For decades, this cosmic blind spot kept the Great Attractor's true nature a complete secret. To pierce this veil, scientists like Alan Dressler turn to technology that sees what our eyes cannot. Infrared and radio telescopes can cut through the obscuring dust, and their early glimpses revealed part of the truth. The Great Attractor is not a single, impossible object, but likely an immense concentration of mass, a vast supercluster of galaxies thousands of times more massive than our own, whose collective gravity creates this cosmic current. Yet, even this staggering amount of visible matter did not seem to fully account for the strength of the pull, leading to theories that it is also anchored by a deep well of dark matter, the invisible scaffolding of the universe. Our understanding took another leap forward when we realized this attractor is not the end of the journey, but merely a waypoint. It is itself being pulled, part of a far vaster river in the cosmic web. We now understand our local universe as part of the Laniakea supercluster, a filamentary structure of 100,000 galaxies stretching over 500 million light-years, and the Great Attractor is simply the central gravitational anchor, the downtown of our cosmic metropolis. This ongoing mystery exemplifies a profound truth about our place in the universe. So much of the cosmos is hidden from our direct view, not by distance, but by the very stars and dust of our own home. Unraveling the secret of the Great Attractor is more than mapping a destination. It is about finally seeing the full map of the currents that guide us and understanding our true address in an impossibly vast neighborhood. Drifting further into the cosmic tapestry, we find a galaxy that appears almost too perfect to be real. Known as Hoag's object, this stunning structure resembles a brilliant golden pearl set within a perfect azure blue ring of stars, all suspended against the velvet black of space. A vast, seemingly empty gap separates the luminous core from the outer ring, creating a cosmic bullseye of breathtaking symmetry. Discovered by astronomer Arthur Hoag in 1950, this singular galaxy spans roughly 100,000 light-years, placing it on a scale similar to our own Milky Way, yet its architecture could not be more different. The central core is a dense sphere of aging yellow stars, while the outer ring blazes with the blue light of younger, hotter suns and the pink glow of active stellar nurseries. The profound mystery lies in the dark gap between them, a chasm where very few stars are found, and no visible structure connects the two distinct components. How could such a perfectly segregated system form and maintain its pristine shape over billions of years? The most intuitive theory points to a cataclysmic collision where a smaller galaxy once plunged straight through the heart of a larger disk galaxy. Such an event could have ripped the disk apart, scattering its stars into a ring while leaving the central bulge largely undisturbed. Yet, there is no evidence of a surviving perpetrator galaxy nearby, no telltale debris of a recent cosmic crash. The ring is too symmetrical, too perfectly circular, lacking the distortions and tidal tails that such violent encounters usually leave behind. Another compelling idea involves internal resonance, where gravitational forces within the galaxy itself create stable zones that shepherd stars and gas into specific orbits, much like the gravitational harmony that creates the gaps in Saturn's rings. These resonances could theoretically clear the central gap and sculpt the ring over eons. However, the sheer scale and perfection of Hoag's object push even this elegant theory to its limits. The age difference between the old core stars and the younger ring stars adds another layer of intrigue, suggesting a complex history of star formation that unfolded in distinct chapters. Hoag's object stands as a profound challenge to our models of galactic evolution. It is not a messy spiral or a featureless ellipse, but a third, rarer class of galaxy that simply does not fit the standard narrative. Its existence serves as a powerful reminder that the universe has more than one way to build our island of stars. This celestial rarity compels us to look deeper into Hubble's deep field images, searching the crowded void for other such perfect circles, other cosmic accidents that might just be the key to rewriting our galactic storybooks. While we map the grand architecture of distant galaxies, a more intimate mystery has been circling our own world for decades. The legend of the Black Knight satellite tells of an ancient, alien object in polar orbit around Earth, a silent watcher whose origins predate human spaceflight. Stories claim it has been transmitting strange signals since the 19th century, a piece of extraterrestrial technology monitoring our development from the void. The myth itself is a patchwork of misunderstood events and genuine space debris, woven together by our innate desire for cosmic connection. Its origins are often traced back to the 1950s, when amateur radio operators began picking up unusual delayed echoes, signals that seemed to bounce back from an unknown object in space. These reports became entangled with earlier accounts, including claims that Nikola Tesla himself intercepted a repeating, intelligent signal from beyond Earth in 1899. Decades later, grainy photographs from early NASA missions were said to show a dark, unidentified object, which enthusiasts quickly labeled as the definitive proof of this orbital sentinel. The truth, as spaceflight historian James Oberg and other debunkers have carefully documented, is far more mundane but no less fascinating. The so-called Black Knight is almost certainly a collage of misidentifications. The famous object in the NASA photographs was identified as a thermal blanket lost during a spacewalk, a piece of human refuse tumbling aimlessly in the vacuum. Other sightings align perfectly with known debris from old satellites or spent rocket stages. The mysterious radio signals were likely natural phenomena from Earth's magnetosphere or simple interference, their patterns misinterpreted by hopeful listeners. So why does this legend persist with such tenacity? It taps into a profound and ancient human narrative, the idea that we are not alone, that someone or something is out there watching. The Black Night is a modern myth, a Rorschach test in the sky where we project our deepest hopes and fears about the universe. It represents our longing for a cosmic sign that we are part of a larger story, even if that sign turns out to be a lost piece of our own technology. This enduring tale teaches a vital lesson in our search for truth. It reminds us to cherish the wonder that drives us to look up, while also wielding the sharp tool of skepticism to separate signal from noise. For every genuine cosmic mystery, there are countless earthly stories we tell ourselves, each one a reflection of our eternal curiosity about the dark just beyond our reach. That longing for connection in the void finds its ultimate expression not in a myth, but in a genuine, chilling imprint on the very canvas of the universe. A profound cold spot stains the cosmic microwave background, the ancient light from the dawn of time. This is not a minor fluctuation, but a vast, frigid region billions of light years across, a place significantly colder than our models of the Big Bang's afterglow can easily explain. Discovered by the Wilkinson Microwave Anisotropy Probe, this anomaly is not just a curiosity. It is a deep freeze that challenges our fundamental understanding of the cosmos. The cosmic microwave background is the remnant heat from the universe's birth, a nearly uniform blanket of radiation that fills all of space. Tiny variations in its temperature are expected, the seeds from which galaxies would eventually grow. But the cold spot is different. It is too large and too cold to fit comfortably within the standard model of cosmology. What could possibly create such a colossal cold patch in the infant universe? One leading theory suggests it is a supervoid, an immense and mostly empty region of space trillions of light-years in volume. As light travels through such an underdense region, it loses energy, a process known as the integrated Sachs-Wolf effect, which would make the background radiation appear colder in that direction. The problem is, the scale of the void required to produce the observed temperature drop is staggeringly large, pushing the limits of what we believe is structurally possible in the cosmos. The sheer improbability of such a vast nothingness has led to a far more radical proposal. Cosmologist Laura Mersini-Houghton has put forward the extraordinary idea that the cold spot is not a void at all, but a bruise. It could be the imprint of a collision between our universe and another bubble universe in the vast multiverse. In this breathtaking scenario, the interaction between our cosmos and a neighboring one in its earliest moments would have drained energy from that region, leaving behind this permanent cosmic scar. While this multiverse hypothesis is controversial, it highlights the desperate need for an explanation that matches the data. The cold spot resists all simple answers, forcing cosmologists to confront the limits of their knowledge. It is a fossil from the first moments of everything, a puzzle written in the cold language of primordial light. Investigating this relic is not just about mapping a cold patch. It is about reading the story of our ultimate origins, a tale that may be far stranger and more wonderful than we ever dreamed. This Relic Galaxy, NGC 1277, is a living fossil drifting through the Perseus cluster. While most galaxies grow and change by consuming their smaller neighbors, this one has remained in a state of arrested development for 10 billion years. It is a cosmic snapshot from the universe's youth, a place where time itself seems to have stood still. Discovered just 220 million light-years away, its most startling feature is the monster lurking in its core. The supermassive black hole at the heart of NGC 1277 is not just large, it is colossally disproportionate, weighing in at a staggering 17 billion times the mass of our Sun. This behemoth makes up a full 14% of the galaxy's entire central bulge mass, a figure that defies all modern scaling relationships. In our local universe, a galaxy of this size would typically host a black hole comprising only about 0.1% of its bulge mass. This ancient giant breaks all the rules. Astronomer Ignacio Trujillo, who has meticulously studied this system, describes it as a clear outlier. Its stars are exclusively old, red, and metal-poor, indicating that the galaxy formed in a single, furious burst of star formation in the distant past and then simply shut down. It never experienced the galactic cannibalism that shapes modern galaxies like our own Milky Way, which has steadily grown by tearing apart and absorbing smaller dwarf galaxies over eons. How did this happen? The leading theory suggests that NGC 1277 was born in an unusually dense region of the early universe, where vast amounts of gas collapsed directly into both the galaxy and its central black hole in one rapid, catastrophic event. After this initial feast, the black hole may have unleashed such powerful outbursts that it blew away all the remaining star-forming gas, leaving the galaxy starved and dormant. Alternatively, it may have been flung into a fast-moving orbit within its cluster, a cosmic runaway that never settled down long enough to merge with another galaxy and trigger a new chapter of stellar birth. This Relic Galaxy forces a profound question upon us. Was its path a cosmic fluke, or are there countless other such primordial time capsules hiding in plain sight, each holding secrets about the violent and efficient birth of the first galactic structures? Finding more of these fossils is now a key goal for astronomers, as each one offers a pristine window into the conditions of the ancient cosmos, challenging our most fundamental stories of how a galaxy is meant to live and die. Even as we map the ancient relics of the cosmos, our newest telescopes are revealing structures so strange they defy all existing categories. They are called odd radio circles, or ORCs, and they appear as faint, ghostly halos on radio telescopes, immense rings hanging in the void with no visible source to explain their origin. Discovered in 2019 by the Australian Square Kilometre Array Pathfinder, these enigmatic circles are colossal, each one spanning hundreds of thousands of light years, large enough to engulf entire galaxies. The most baffling part is what they are not. When astronomers point optical telescopes at the same coordinates, they find nothing, or at best, a quiet, unassuming galaxy at the very center of the radio ring. These are not the glowing nebulae or the familiar spirals we are used to. They are phantoms, visible only in the specific wavelength of radio waves. Professor Ray Norris, one of the leading scientists investigating them, describes the moment of discovery as one of pure astonishment, finding something in the sky that nobody had ever seen before and that nobody could immediately explain. So what could possibly project such vast, perfectly circular emissions across interstellar space? The leading theories point to titanic shockwaves. One idea suggests they are the aftermath of a starburst event, a period of frantic star formation so intense that the combined force of countless supernovae blows a spherical bubble into the surrounding gas. Another proposes an eruption from an active galactic nucleus, where a supermassive black hole belches out a colossal, symmetrical burst of energy. Yet, both of these explanations struggle to account for the ORCs' remarkable uniformity and their apparent isolation. If they are shockwaves, why do we see only the crisp, circular edge and not the chaotic interior of the event that created them? The very cleanliness of their form has pushed theorists to consider even more exotic possibilities. Could these rings be the throats of wormholes, their gravitational lensing creating a circular imprint in radio light? Might they be the result of annihilating dark matter, a substance we cannot see directly, but whose violent interactions could be broadcasting these strange signals? Each new observation with advanced arrays like a SKAP deepens the mystery, confirming that ORCs are a genuine new class of astronomical object. Their discovery is a powerful testament to how new eyes on the cosmos continually rewrite our textbooks. For centuries, we studied the universe in visible light, but now, by listening to the radio whispers of space, we are finding an entire hidden landscape of phenomena, a universe within the universe, teeming with structures we are only beginning to dream of. Deep within our galaxy, a dead star spins at an impossible rate, and circling it is a world forged from a material more precious than any on Earth. This is the Diamond Planet, a celestial object that challenges our very definition of a world. Officially catalogued as PSRJ 17191438b, this extraordinary body orbits a pulsar, the rapidly spinning corpse of a massive star. The pulsar itself is a cosmic lighthouse, its beam of radio waves sweeping through space with metronomic precision. It was through tiny, telltale variations in this pulse rate that astronomers, led by Matthew Bales, detected the subtle gravitational tug of an orbiting companion. They were not expecting to find a planet, they were expecting to find a star. The data revealed something far stranger. The companion object was far too small to be a normal star, yet far too dense to be a conventional planet. Calculations of its mass and radius pointed to a staggering conclusion. This was the crystalline heart of a star, a remnant core of carbon and oxygen that had been crushed under its own immense gravity. The pressures involved are almost beyond comprehension, squeezing the carbon into a rigid, crystalline structure, a planet-sized diamond. This cosmic gem did not form in a calm nebula of dust and gas like the planets in our solar system. Its origin story is one of cosmic vampirism. It began as a white dwarf star in a binary system with the pulsar. Over eons, the pulsar's intense gravity siphoned material away from its companion, stripping the white dwarf down to its bare, ultra-dense core. This violent process left behind a skeleton of crystallized carbon, a glittering tombstone for a star that was almost completely consumed. What would it be like to stand on such a world? The landscape would be dark and eerily still, lit only by the faint, flashing beacon of its pulsar sun. The ground beneath your feet would not be rock or ice, but a vast, seamless surface of diamond, unyielding and cold. The idea of life existing there seems fantastical, with no atmosphere to speak of and bathed in intense radiation from the pulsar. The Diamond Planet is a monument to sterility. Yet its existence is profoundly significant. It proves that planets can be born from stellar cataclysms, that they can be made of materials we once thought were exclusive to jewelry stores. This discovery shatters the mold, forcing us to expand our imagination and accept that the universe is capable of crafting worlds from the most unexpected of substances. The galaxy's rhythm holds a beat far more dangerous than we once believed. Beyond the silent orbits of stars, a theory suggests our Milky Way can unleash titanic waves of energy, periodic tsunamis of cosmic rays that sweep out from its core and wash over every star in their path. These are the galactic superwaves, a concept proposed by astrophysicist Paul Laviolette, painting a picture of a galaxy that is not serene but periodically volatile. The idea is that our galactic center, home to the supermassive black hole Sagittarius A star, does not rest quietly. It may experience episodic explosions or intense outbursts of energy, perhaps from matter falling into the black hole or from resonant cycles of star formation and death. These events would not produce light or gamma rays like the Fermi Bubbles. but would instead generate a shockwave of high-energy atomic nuclei and particles, a flood of cosmic radiation that propagates outward through the galactic disk. This wave would take thousands of years to travel, but when it arrives, it does not pass unnoticed. The evidence for these ancient cataclysms, La Violette argues, is buried right here on Earth. Ice cores from Greenland and Antarctica show layers with sudden, dramatic spikes in nitrate concentrations and rare isotopes like beryllium-10, which are telltale signatures of intense cosmic ray bombardment. Similar signals are locked in ocean sediment layers, all pointing to periods in our planet's history where the sky was filled with a rain of particles from a distant galactic event. The potential consequences are staggering. Such a deluge of radiation could punch through our atmosphere, depleting the ozone layer and showering the surface with muons and other secondary particles. This could trigger climatic shifts, cause mass mutations in life, and has even been theorized to prompt geomagnetic reversals by disrupting the currents in Earth's molten core. The timeline is chillingly plausible. Some researchers suggest these superwaves might correlate with past mass extinction events, moments where life on Earth was reset by a force from the deepest reaches of space. Yet, for all its compelling connections, the superwave theory remains deeply controversial. Many in the mainstream scientific community are skeptical, pointing to the lack of a smoking gun, a direct observation of such an event occurring in our galaxy today. They argue that the ice core data could be explained by more local phenomena like supernova within a few hundred light years. The debate hinges on frequency and scale. Are these waves a regular, predictable cycle, or are they rare, cataclysmic exceptions? The uncertainty is the very heart of the mystery. This idea fundamentally challenges our isolation. It dares to connect the most dramatic events in our biological history to the violent mechanics of the galactic core, suggesting that the evolution of life on our pale blue dot is intimately tied to the heartbeat of a giant. We are not merely inhabitants of a solar system, but passengers on a starship sailing through a galaxy that can, without warning, turn stormy. That galactic heartbeat finds its echo in the faint, primordial light of the early universe. Suspended in the deep field images from our most powerful telescopes are colossal clouds of glowing gas, each one a ghostly island spanning hundreds of thousands of light years. Astronomers call them Lyman-Alpha Blobs, and they are among the largest and most enigmatic structures we have ever identified. These are not compact galaxies, but vast, diffuse halos of hydrogen, shining with a specific, eerie ultraviolet light. Their discovery in deep space surveys revealed something astonishing. They are often found at the hearts of protoclusters, the dense knots of matter that would one day evolve into the great clusters of galaxies we see today. These blobs are cosmic construction sites on an epic scale. The central mystery is what makes them shine so brightly. The Lyman-alpha radiation is emitted when electrons within hydrogen atoms fall to a lower energy state, but the sheer intensity of the glow from such a vast volume of space demands an incredible power source. Astronomers like Chuck Stadel, who has pioneered their study, have proposed several theories. The light could be driven by furious bursts of star formation happening inside the embedded galaxies, so intense that the radiation pressure pushes the light out to illuminate the entire gaseous halo. Alternatively, the glow might be powered by active galactic nuclei, where supermassive black holes at the centers of young galaxies unleash torrents of energy, lighting up the surrounding gas like a cosmic lantern. A third, more exotic idea involves cold accretion flows, where vast rivers of pristine, cold gas from the cosmic web funnel directly into the blob, heating up through gravitational collapse and causing the entire structure to glow. Yet, no single theory neatly explains every blob we observe. Some appear quiet with little internal star formation, while others are frenetic hubs of activity. This tells us that we are likely seeing a universal process, the assembly of the first great structures, unfolding in multiple ways. These blobs are more than just clouds, they are the wombs of galaxy clusters. The hydrogen gas they contain is the raw material for billions of future stars, and their immense gravity is drawing in more matter, building the foundations for the cosmic metropolises we see in the modern universe. Studying them is like looking at the blueprints for a city while the steel girders are still being raised. Their persistent mystery is a powerful driver for the next generation of telescopes, instruments that will peer into their hearts with greater clarity. Understanding Lyman-Alpha Blobs is to understand how the greatest structures in the cosmos were born from formless clouds of primordial gas, a fundamental step in the story of how our universe grew from simplicity into its present-day complexity. The universe speaks in whispers, but sometimes it shouts. Across the gulf of space, in flashes lasting barely a millisecond, cosmic explosions release more energy than our sun does in 80 years. These are fast radio bursts, or FRBs, the most fleeting and furious signals we have ever detected. Their story began in 2007, when astronomer Duncan Lorimer was sifting through archived data from a radio telescope in Australia. He found a single, spectacular spike of energy that had been recorded 6 years earlier, a burst so powerful and so brief it defied all classification. Since that first discovery, hundreds more have been detected, flashing from random directions across the sky without warning. The mystery only deepens with their variety. Some are one-time events, a solitary scream into the dark. Others are repeaters, firing off multiple bursts from the same patch of sky, following patterns that are erratic yet undeniable. This fundamental difference suggests there may be multiple cosmic engines capable of producing these incredible flashes. For years, the leading theories were cataclysmic. Scientists proposed the collapse of ultra-dense neutron stars, the violent mergers of stellar corpses, or even the snapping of cosmic strings, hypothetical defects in the fabric of space-time. Any single titanic event could, in theory, release the staggering energy observed. Then, in 2020, a breakthrough occurred within our own galactic neighborhood. A magnetar, a highly magnetized neutron star, entered an active phase and let out a roar. The radio burst that erupted from it was a perfect match for the signals we had been detecting from distant galaxies. Finally, we had a confirmed source. The immense magnetic field of a magnetar, trillions of times stronger than Earth's, can store phenomenal energy. A starquake on its solid, crystalline crust could release that energy in an instant, creating a fast radio burst. Yet this single answer has not closed the case, it has only opened more doors. While some FRBs are now confidently linked to magnetars, many others do not fit the profile. Their energy is too great, their patterns too complex, or their locations point to environments unlike any magnetar we know. The repeating bursts in particular present a profound puzzle. What natural process can fire again and again after such a colossal release of power without destroying itself entirely? The very persistence of these repeaters keeps more speculative ideas alive, including the remote possibility of artificial origins, like powerful beams from extraterrestrial light sails. The true significance of FRBs may not be their mystery, but their use. As these bursts travel billions of light years, they pass through clouds of diffuse gas that subtly distort their signal. Astronomers have realized they can use these distortions as a tool. Each FRB is a cosmic probe, allowing us to map the otherwise invisible matter scattered between galaxies, weighing the missing atoms that make up the cosmic web. We are now in an era of rapid discovery with dedicated telescopes scanning the skies around the clock. Every new flash is a data point, a piece of a puzzle that is slowly coming into focus. They remind us that the cosmos is not a still life, but a dynamic arena where transient, violent events can illuminate the darkest corners of our understanding. Deep within the heart of our own Milky Way, a colossal structure is in motion. This is the galactic bar, a dense concentration of billions of stars and immense gas clouds stretching thousands of light years across the galactic center. We have long pictured it as a rigid, stable fixture, the central hub of our spiral home, but the latest data paints a far more dynamic and unsettling picture. The bar is not just rotating, it is twisting, its motions deviating from the predictions of our most sophisticated computer models. To see this structure at all, astronomers must peer through the obscuring dust of the galaxy's plane using the eyes of infrared and radio telescopes. These instruments reveal a central bar that acts as a powerful engine, funneling gas inward to fuel star birth and influencing the rotation of the entire galaxy. Yet its own behavior is now the subject of intense debate. Researchers like Andrea Kunda have meticulously tracked the velocities of stars within the bar, creating a map of its complex dance. Their findings suggest something remarkable. The bar's rotation may be slowing down, or it could be interacting with the invisible halo of dark matter in ways we never anticipated. This unseen matter, which makes up most of the galaxy's mass, might be exerting a frictional drag on the bar, gradually sapping its angular momentum. The implications ripple outward. Galactic bars are not permanent structures. They form, they evolve, and they can even dissolve over billions of years, reshaping the entire galaxy in the process. The twisting of our own bar is a live snapshot of this cosmic evolution, a sign that the Milky Way is a complex, living system with hidden mechanics still at work. Understanding its motion is like finding the heartbeat of our galaxy. It tells the story of where we came from and hints at our ultimate fate. Will the bar eventually wind up, triggering a final burst of stellar creation, or will it disperse, transforming the Milky Way into a featureless elliptical galaxy? This great twisting engine at our core holds the answers, a reminder that even our home in the cosmos is a work in progress, its final form still being written in the language of stars and dark matter. This destructive reality of stellar winds finds a spectacular example in a world literally blowing away before our eyes. HD 209458b is a gas giant orbiting dangerously close to its sun, a star so intense it is actively boiling the planet's atmosphere into space. With each close pass, torrents of stellar radiation strip away the gaseous layers, creating a magnificent million-mile-long tail of hydrogen and other elements that streams behind the planet like a cosmic comet. This is not a slow geological process, but a violent, ongoing demolition. The discovery was made using a technique called transit spectroscopy. When the planet passes in front of its star from our viewpoint, the starlight filters through the planet's extended atmosphere. By analyzing the specific colors of light that are absorbed, astronomers like Alfred Widel-Majer were stunned to detect a huge cloud of hydrogen enveloping the world, far larger than the planet itself. They had caught a planet in the act of disintegration. The forces at work are brutal and relentless. Photoevaporation occurs when the star's high-energy ultraviolet radiation pummels the upper atmosphere, heating the gas until individual atoms achieve escape velocity, flying off into the void. This process is supercharged by the immense tidal forces, a gravitational tug of war that locks the planet in a close, roasting orbit and further stresses its atmosphere. The result is a continuous, high-speed solar wind of planetary material being blasted into the darkness. This bizarre phenomenon offers a sobering lesson in planetary evolution. We often think of worlds as stable, permanent places, but HD 209458b reveals a different truth. It shows us the fate that may await many hot Jupiters and even smaller, rocky planets that orbit too close to volatile stars. If a giant planet can be torn apart so visibly, what chance would a fragile, Earth-like world have in such an inferno? Observing these evaporating planets provides a real-time laboratory for understanding atmospheric loss, a critical factor in the search for habitable worlds. It forces us to ask not only where life could begin, but also for how long it could possibly survive before its sky is literally blown away. The true architecture of the cosmos is written in invisible ink. All the stars, galaxies, and brilliant nebulae we can see are merely decorations pinned to a hidden framework, a skeleton of dark matter that holds everything together. These are the dark matter halos, vast, spherical clouds that envelop every galaxy, including our own Milky Way. They are the universe's greatest ghost, a substance that does not emit, absorb, or reflect any light, yet whose gravitational pull dictates the motion of stars and the very fate of the cosmos. We cannot see them, but we can see their shadow in the way galaxies spin. In the 1970s, astronomer Vera Rubin made a discovery that shattered our classic view of galaxies. By meticulously measuring the rotation speeds of stars in the Andromeda Galaxy, she found something deeply puzzling. According to Newtonian physics, stars on the outer edges of a galaxy, far from the central mass, should orbit much more slowly, just as Pluto crawls around our Sun compared to Mercury. But Rubin's data showed the opposite. The outer stars were whipping around just as fast as the inner ones. The only possible explanation was that the galaxy was embedded in a huge halo of invisible matter, its gravity providing the extra pull to keep those distant stars from flying off into the void. This missing mass problem was our first direct clue to the dark universe. Another line of evidence comes from gravitational lensing, a phenomenon predicted by Einstein where the gravity of a massive object bends light like a lens. When astronomers look at distant galaxies, they sometimes see their light stretched and distorted into arcs and rings. The amount of distortion is far greater than the visible matter in the foreground galaxy can account for, revealing the presence of its immense, unseen dark matter halo, warping the fabric of space itself. To understand how these halos shape the cosmos, scientists run colossal computer simulations like the famous Millennium Run. When they model the universe with only normal matter, the result is a formless, disappointing haze. But when they add the gravitational influence of dark matter halos, the simulation springs to life, weaving a cosmic web of filaments and clusters that perfectly mirrors the universe we observe. These halos act as gravitational seeds, drawing in normal gas that then cools, condenses, and ignites into the first stars and galaxies. So what is this mysterious substance that makes up roughly 85% of all matter? The leading candidates are as elusive as they are fascinating. WIMP, or weakly interacting massive particles, are theoretical heavy particles that rarely bump into normal matter, passing through our planet as if it were empty space. For decades, ultra-sensitive detectors buried deep underground have been waiting for the faint, once-in-a-lifetime ping of a WIMP collision, but so far the silence is profound. Another promising candidate is the Action, an ultralight particle trillions of times less massive than an electron. While individually insignificant, a universe flooded with actions could account for the missing mass, and experiments are now tuning in, hoping to convert these ghostly particles into microwaves. The search is one of the most profound in all of science. We are surrounded by an ocean of dark matter, feeling its tides in the motions of galaxies, yet we still do not know what it is. Unlocking this secret would not just solve a cosmic puzzle, it would open a door to a whole new physics, revealing the true nature of the reality we inhabit. Humanity's journey to decode the cosmos is a story of ever-evolving questions. For centuries, our ancestors looked to the stars and saw the hand of gods, weaving myths to explain the movements of the sun and the patterns of the constellations. The planets were wandering deities and comets were omens of disaster. This changed when thinkers like Copernicus and Galileo pointed their rudimentary telescopes skyward, daring to suggest that Earth was not the center of all things, but a single world orbiting a star. That shift from a geocentric to a heliocentric universe was more than a scientific correction. It was a profound redefinition of our place in the cosmos, a humbling that expanded our vision. Each leap in technology, from the first glass lenses to the mighty orbital observatories of today, has peeled back another layer of the unknown, only to reveal deeper mysteries waiting beneath. The philosopher and astronomer Carl Sagan captured this beautifully when he reminded us that the universe is not obliged to conform to our human expectations. It exists on its own terms, and our task is to patiently listen and observe, refining our tools and our thoughts. Consider the great mysteries of the past. For generations, those faint, fuzzy patches in the sky known as nebulae were complete enigmas. Were they distant solar systems in the making, or simply clouds within our own galaxy? It took the colossal mirror of the Hooker telescope and the meticulous work of Edwin Hubble to prove they were entire galaxies, island universes drifting in a vast cosmic ocean. Later, the discovery of quasars, points of light that outshine 1,000 galaxies, baffled scientists for years. Were they nearby stars or something else entirely? Through global collaboration and innovation, we came to understand them as the furious hearts of distant galaxies, powered by supermassive black holes. Each of these solutions did not mark an end to inquiry, but a new beginning. They set a powerful precedent for the 22 structures we explore today. The wow signal, the giant arc, the dark flow, these are the modern equivalents of those once perplexing nebulae. They are the puzzles of our time, waiting for the next generation of tools, the next spark of insight, to transform them from bewildering anomalies into understood phenomena. This long tradition of exploration shows that our quest is not about finding final answers, but about the perpetual act of looking upward with both wonder and rigor. Every mystery solved is a doorway to a new, more fascinating question, inviting us to continue the greatest adventure there is, the exploration of a universe that forever challenges us to see more and to be more curious. Our journey through these 22 cosmic enigmas leaves us not with answers, but with something far more valuable, a deeper and more profound set of questions. From the fleeting whisper of the wow signal to the impossible scale of the giant arc, each structure is a testament to a universe that refuses to be neatly categorized. These are not mere astronomical curiosities, they are fundamental challenges to our models, forcing us to rewrite the textbooks and reconsider our place in the grand scheme. The universe reveals itself not as a placid void, but as a dynamic arena of immense forces and bewildering architectures, where a dying star can sculpt a perfect rectangle and an invisible river of galaxies flows toward an unseen shore. This grand tour humbles us, reminding us that for all our knowledge, we have only just begun to explore the shoreline of a vast and mysterious ocean. Carl Sagan's words resonate now more than ever. Somewhere, something incredible is waiting to be known. This is the true legacy of these mysteries. They are not dead ends for science, but its very lifeblood. Each anomaly is a beacon guiding the next generation of telescopes and the next spark of human curiosity. They invite us all to become explorers, to look up at the night sky and see not just points of light, but a canvas of endless possibility. Which of these bizarre structures captured your imagination the most? Was it the silent, geometric perfection of the red rectangle, or the ghostly, colossal rings of the odd radio circles? Share your thoughts in the comments below, and if your sense of wonder has been ignited, subscribe for more journeys to the edge of our understanding. The cosmos is whispering its secrets, and the greatest discoveries are still waiting just beyond the light of our brightest stars.